Okay, in today's video, we're going to go over how to address low page life expectancy in SQL Server. So I had a question posed on the PLE video, basically saying, "Hey, how do we address low PLE?" So here are some of the things that I just kind of jotted down when thinking about it, and so I'll go through them. And the ones that are a little bit bigger here, we're going to go into a little bit more detail. But I'll give you these all the items that I kind of jotted down, and if you guys have additional questions on these other ones, just let me know. The first thing you can do is increase the amount of memory available in SQL Server. So by default, I don't know if you know, but by default in SQL Server, they actually configure the instance to use all of the memory available on the server, which is generally not a good idea. So it's usually a good idea to go in there and limit that. But what happens is if you over time you decide to upgrade your RAM or something like that on your server, you may not remember to go in and reconfigure the memory and increase upsize that memory to be uh, proportional to the amount of memory you have on the server. So that's just something you can check real quick. Just make sure that you're using the memory that you already have on the server. The next thing you can do is use Query Store or similar tools. I haven't used Query Store too much, but I've used other tools which have really alleviated the need to run Query Store. So I've used things like Spotlight on SQL Server, and I've also used more recently, a lot more, is this SolarWinds tool named Database Performance Analyzer. And what these tools do is they go out and scan the queries that are running on the server and identify the inefficient ones so that you can go in and start targeting those and figure out where you want to tune. And obviously, these are the things I want to focus on in this video is, you can optimize your queries. And in order to do that, you first have to identify those queries. That's what Query Store and those other tools allow you to do. Or you can also use like the Management Studio reports, performance reports, which identify like the top 10 queries from various perspectives. And you want to monitor your server regularly. So this is not something you can just do once and forget about it. Your database is evolving over time. You've got new queries coming in for users. You might have application upgrades that introduce new queries to the server, and so you have to keep a keen eye on things over time. You can't just tune once and forget about it. It's an ongoing process. Next thing you can do is check for planned cache evictions. So in addition to data being cached, SQL Server and all databases will cache plans, which are basically how it's a strategy for how they're going to go about and get to the data that you're trying to query. So if you've got plans that are getting aged out, what happens is the database is going to, when it encounters that query again, it's going to have to go out and gather a new plan, which is a very expensive operation. That's where the database goes and looks at all the information it has available to it and comes up with a strategy on how to get to your data. So it's going to figure out, well, in order to go and most efficiently query this data, I'm going to use this index and I'm going to scan it in this way, or I'm going to do an index lookup, which means I'm going to hop through the B tree in order to get to the data page or pages. And the last thing I have here is enabling address windowing extensions. Now, this one only really applies to 32-bit systems, but it's a way for you to use and allocate more memory than 4 gig on a 32-bit system. So again, that's most systems now are 64-bit, but just in case, I included it just for completeness here. Okay, so just a quick review. What is PLE? So PLE stands for Page Life Expectancy, and it's really how long I can expect a page to remain in memory after it's been loaded from disk. The buffer cache is memory that SQL Server uses in order to serve queries. And accessing data in memory is orders of magnitude faster than retrieving it from disk. That's why we want to use memory as much as we can. But the trick is we need to be using the memory as efficiently as possible. So data gets loaded in memory in units of pages, at least in SQL Server. That's what they're referred to as pages. That's why it's called page life expectancy. It's also referred to as blocks in other relational database management systems such as Oracle. And the size of the cache is limited by the server hardware you're running on. So there's limits here. That's why we have to use things as efficiently as possible. If we had no limits, we really wouldn't have to worry about it. We could just cache everything in the database. But typically we can't really do that feasibly in most systems. All right, so let's just dig into it a little bit further. So what I have here is just a simple picture of a database buffer cache. Your database, these are like your disk files, and then this is like your session memory area. Okay, so this is shared, this database buffer cache, and these are your database files. So the key concept here is the size of this database buffer cache is limited. Let's say it's, I don't know, let's say it's 8 GB, okay, on your server. So, and what happens is once that 8 GB fills, pages need to be aged out. And typically, a relational database is going to have some sort of algorithm it follows for aging those pages out. And the simplest one is last in, first out. So the oldest page gets aged out first. So let's say a page got in loaded into memory yesterday. And that's the oldest page that would be aged out first. And sessions will pull from the cache. They don't pull directly from the disk in a database. So what happens is every page that gets returned to this user session actually has to come out of the buffer cache. And if it's not in the buffer cache, has to load it from disk. So it's bad when something gets aged out of the buffer cache because it's not going to be eligible to be returned to a user session. So our goal is to minimize the number of pages that actually get loaded into the buffer cache. And the way to do that is to tune your queries. So I've got a couple of queries here. I've got select star from order history. So there's no choice here for the database. It's going to have to scan your table, the order history table, in order to fulfill this query and return all the results to the user who issued this query. And so let's say that the order history table is 8 GB, which is the size of our buffer cache. That means that the entire table is going to need to come in to the buffer cache. And let's assume that order history didn't have any entries in the buffer cache. That means everything else that's in the buffer cache needs to get dumped in order for that order history data to come in. And if for some reason order history is even bigger than the database buffer cache, it's going to have to start swapping out those older pages in order to bring the last ones in and fulfill the query. So that's going to be a very expensive operation. It's going to age out everything in your query. And this is something that would cause a very low page life expectancy because things would get aged out, almost immediately. And you'll see cases where, it's just only on the mirror of, seconds, as opposed to thousands of seconds is usually what you want to see. And I got another query here now where it's selecting specific columns from the order history table, which is another good technique. You don't want to be pulling uh, more columns that you need because you could actually have indexes that contain all the data. And so you don't even have to do the page lookup to go to the data page to get the data. You get everything out of your index. And here you're going to order history, and you're specifying a very specific row, so where the order ID equals 100. So you're going to get all of the data in the order history table that's associated with order ID 100. And let's say that there's only one row. We've got everything rolled up into this order history and there's only one row per order. Well, that means that I've only got to go through, and let's assume again that I have an index on the order ID column. So that means instead of scanning the entire order history table and pulling in 8 gigs of memory or 8 gigs of data into your buffer cache, you're only going to pull in a few pages because an index structure is a tree. So you've got a B tree structure that, in most cases it's not going to be deeper than 4 levels. And so you're really going to have to go just through those 4 page reads in order to fulfill the query and pull it back to the user. So that's a significant difference from scanning the table, and it's a much more efficient operation. And those are the types of things we want to do in order to tune PLE. Yeah, I just wanted to mention I actually have several other videos that really relate to this topic. So of course I've mentioned I've got a page life expectancy video. That's kind of where the idea for this video came up. I've got another video where I go over SSMS reports, and these are the nice thing about this is you don't need any purchase any tool or anything like that, like Spotlight or DPA, the other tools I've mentioned. These come with SQL Server. And what they allow you to do is find your heaviest queries on your server. You just go to the Management Studio tree, you pick your server, right click, and you go to Management Studio Reports. Of course, go to this video, give you all the information. Then I've got another video where I go into query optimization. So after you identify the queries, what are some things you can do, some strategies you can use, and techniques for optimizing those queries in SQL Server. And last but not least, I've got another video where I go into and show you how to measure the logical I/O associated with your query and actually get hard numbers for your query. So you just issue the set statistics I/O command, and after you do that, when you run your queries, it's going to tell you, hey, this is the number of pages I read from every database object that I had to touch to fulfill your query. So I'll put all the links for these videos in the description of this video. That's it for today. Hey, I appreciate you guys watching the video. I hope you enjoyed it. If you did, please like, subscribe, and comment. Drop your questions below, and I'll see you guys next time.